guys, Mr. Mackey here. Now we're going over surds for the past couple of days, and I introduced you yesterday the rationalising of the denominator, and I set you the challenge to rationalise the denominator of this problem. Now there's actually two ways you can do it, and both ways will give you the same answer. So I'll show you both ways very quickly, just so you know there is an alternative. The first way, so I'm going to split it down here, so there's two different methods. The first method is if you just did root 27 and root 12 and you just rationalised it as root 12. So you do root 27 multiplied by root 12 and root 12 here. So what I showed you yesterday. The other method is if you simplify these first. So you do root 27 simplified becomes 3 root 3 and root 12 becomes 2 root 3 and you rationalise it as that. So it becomes this. Now when you did it from this method, you end up at the numerator becoming root, because it's quite a complicated one, I'll use my calculator, 324. And the denominator will become 12. For this one, the numerator will become 18. The reason why? Well, 3 multiplied by 2 becomes 6, root 3 multiplied by root 3 becomes 3, and 6 times 3 gets you 18. And the denominator becomes 12. Why? Because 2 times 2 becomes 4, root 3 times root 3 becomes 3, 4 times 3 becomes 12. Now, when you do this one, 324 is actually 18 squared. So when you root 324, you actually end up with 18 over 12, which is exactly the same as that one. Now we must simplify it because we can't leave it like that. We have to leave it in our simplest form. And when we simplify it, we will end up with 3 over 2, or 1.5, or 1.5. All those are the same. So it doesn't matter which method you used, as long as you got the answer 1.5, or 3 over 2, or 1.5. So today we're going to be looking at rationalising the denominator again, but in a more complicated approach. How complicated? Let's get into it. Now this problem is fairly similar to what we've done before. We still have to rationalise the denominator. However, this time the denominator also includes a rational number. So it actually turns into a sort of algebra problem. It's 5 plus root 5. It's sort of like 5 plus x in a way. Now I want to get rid of that root. Now because of this, we can't multiply our denominator and our numerator by 5 plus root 5 again. Because if we do that, we'll still end up with a surd at the bottom. So we have to think of something to multiply by that will completely get rid of that surd. Now in this case, we will have to multiply it by, for both sides, 5 minus root 5 on both. The reason? I'll show you. When we expand these brackets, we do 5 times 5, that gets us 25. Root 5 times 5 gets us 5 root 5. 5 times negative root 5 becomes negative 5 root 5. And root 5 times negative root 5 becomes negative 5. Now you can tell from this that the surds actually cancel each other out. So 5 root 5 minus 5 root 5 actually becomes 0. So the denominator is now just 25 minus 5. So I'm going to write this under here just so it's a little bit tidier. So the denominator is 5, take away root 5, and that becomes 20. We have rationalised our denominator. But we still have our numerator, which is 5, take away root 5, multiplied by 1. So let's write that at the top. 5 minus root 5. Do we simplify it? Well, we don't need to, because the root 5 can't be simplified. The 5 can be, but the root 5 can't, and they're basically all together in one problem. So we could, but it's pretty much easier to just leave it like that. So, when we rationalise the denominator, we change the plus into a minus, or the minus into a plus, whichever one you've got, and you then rationalise it from that approach. Get rid of the surds at the bottom, and if simplifying, simplify it. Pretty straightforward when you think about it. But let's look at another one, just to be sure. So let's now try one where the numerator is not 1, and the denominator now has a minus. So let's give it a try. So, when we rationalise it, instead of doing it with 2 minus root 3 on both, it becomes 2 plus root 3. So 2 plus root 3, 2 plus root 3. Now when you expand the brackets in the denominator, you do 2 times 2, which gets us 4. 2 times root 3 becomes 2 root 3. 2 times negative root 3 becomes minus 2 root 3. And negative root 3 times root 3 becomes negative 3. So let's tie this up a bit. Our denominator just becomes 4 minus 3 because those cancel each other out. So it becomes 1. And the numerator becomes 3 times 2, which is 6, plus 3 times root 3, which is 3 root 3. Now, because our denominator is 1, we can just simplify it to 6 plus 2 root 3. And that's it. Simple as. It's quite straightforward when you think about it. Now, because I've done one with a plus and one with a minus, and these are pretty much the hardest they're going to get for now, wait till tomorrow, let's move on to a challenge. So, your challenge today is to rationalise the denominator of this fraction. What do we need to do? Do we need to change anything? What happens to the numerator? Do we need to simplify? Consider all these questions when solving this problem. Good luck with this, and I'll see you tomorrow for one more episode where we need to rationalise the denominator. How much harder can it get? Stay tuned.